Okay, it doesn't have to look like this. Don't worry about how it looks like. Okay. Okay, you might have to follow us. I thought we remember. Okay, not a big deal. I follow up with you. Is it you is open? You is open? 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 Okay. It's because it's right in, because I dropped a link for you right here. Okay, just a minute. What does it do? Okay. All right, we'll install it. I can help you. Sorry. I thought we went through. Okay, go please open the software. Go ahead and open your software. Go ahead and open your software. When you open your software, could you please go to project, project, everybody's there, project and new. I don't want to save, no, no, I don't want, okay. Did you guys, when you went to project new, did you have this opening? Everybody has the same folder? Cool? Cool? Okay. Jeff, all we did is just we double clicked on this icon here and we just started. If you want to double click on the icon and follow us with us. Okay. So I would like you guys to call this is commercial project and save it in certain locations. So let's go commercial project. So this is my commercial project. It defaults to projects. Does yours default to the same location here under PTW, right? For the time being, guys, let's go to the desktop. Everybody went there. Go to the desktop. Cool. And hit save. Save it in your desktop. Eventually, I would like you guys to put it on the network. We just go copy and put in the network. Thumbs up, Chad. We put it in the desktop, so we named the commercial project and we saved it. Gentlemen, you have just started the project. When you start the project, please make sure that it looks like this. Something similar to this. Let me close my email here so it doesn't pop. Let's start with Darren. Does it yours look like this? Adam? Okay. Zach? Jimmy? Okay. Jeff, when you catch up with us here, we just opened it and we named the project. Project open project. Okay. Expand that one, guys. What I did, I expand it. Expand that little riser. Looks like this. I need thumbs up when you guys are there. Cool. This software, gentlemen, is going to do the following. I'm going to write the steps here that you need to do, that we're going to be doing on it. If you might write, you might have to write it down, or you can follow with your friend Chad because it's actually given right in here in page. Oops. All right, circled. Power system analysis. Page 5 circled. If you guys look at page 5 circled, page 5 circled, these are what I would like you guys to do from SKM PTW. Number one, we need a one-line diagram. So I'm gonna write how do you use this software. Step, how to use it. Let's see how to use. How to use it. Cool. Steps how to use it. The first thing I would like to do is build one-line diagram. That's step number one. Build one-line diagram. The first thing we start, guys, is building a one-line diagram. You're going to see in a second how we build a one-line diagram. Thumbs up, Chad. Step two, we're going to input data in one-line diagram. We're going to populate the one-line diagram with actual data. So when we say a transformer, we're going to go pick an actual transformer. When we say a feeder, we're going to go pick an actual feeder. Populate the one-line diagram with data. How hard would that be? So build it, first build the riser. Second, input the data into the one-line diagram. Third, run analysis. We're going to run the analysis. That's it, 3 steps. Build the riser, input data, run analysis. See how easy that software is to use? run analysis. So today, guys, I would like to use the short circuit analysis component, and hopefully, if we, we can run into the coordination in a second. Otherwise, we might have to do coordination next tomorrow. So that's the steps they need to do. Input, load flow, coordination curves, and from these guys, the outcome that I would like you guys to do, outcome is the following. Number one, I would like you guys to print one line diagram 11 by 17. Print out. You're going to print one. You have them. I'm writing right here, guys, from the sheet. Short circuit report. I would like you guys to do a short circuit report on that. 3 input data or data input report. Data. That's not a data, even close to data. Data input report. Data input report. We have load flow number 4, load flow report. Load flow report from this component. And these are the 3 things I want to emphasize right now. There's coordination curve for the chiller, coordination curve for report for the chiller. These we're going to do them later. Cool. These are the 3 things I want to do right now, and I'll get into the coordination in a second. Can I have thumbs up, Chad? This is how the system works, right? Okay, so I'm going to go start building the riser. Cool. Can I erase this one when you guys have a chance? All right, so I'm going to go start building the riser. As easy as you can imagine. When you open this system, guys, so easy. Everything that you need is in the top right here. Everything, all the components that you need to build your one-line diagram are right here. I'm going to build my one-line diagram and go through it and explain them as I build the one-line diagram. Okay. Now remember, this software is supposed to give you short circuit analysis and coordination. In order to do short circuit analysis and coordination, you need to input data. Let's start by my one-line diagram. I grabbed Jeff, I grabbed yours, guys, here. Here's my one-line diagram. Let's go to my one-line diagram in here. You guys have it in front of you, or riser. Okay, here's a system that I would like to model. I have a generator, a transformer. From the transformer, we go to the termination box. From the termination box, we go to an auto transfer switch into the main panel, into the receptacle and lighting panel. Can I have thumbs up, Chad, that we're building this one? So step by step, your start point always the transformer, the utility transformer. Now, Jeff, we have no control over the utility transformer that Excel can give to us. Do we have any control over the utility transformer? We don't have any control over the utility transformer at all. This is set by Excel. So really our point, the point that we start interfacing is right in here. So instead of this transformer, guys, I'm going to go put a utility, not a transformer. The reason why I don't put transformer, because I don't install the transformer. Excel install the transformer. Anything that you don't install, you don't put in the riser. So what I'm going to do, guys, instead of this big box here, I'm going to say utility. I'm just going to install. Here's the symbol that we use for this. We use this symbol, utility, U for utility. Okay, so let's go input that symbol here. I'm going to go right to the top here and get a utility. So where's my utility? Can you guys see that U? Everybody can see that? Click on that one. Now you're holding. By the way, this is not a drafting. This is modeling. You hold the component, you slam it against that background, and it sits there. Can you guys see that I'm holding a component? Pick any location. You can zoom in and out, but let's just pick in here and throw my mine right in here. Do you guys, and you can zoom. If you have a zoom, guys, it's awesome now. Everybody got a utility like this? Thumbs up, Chad. Okay, it's working, yours? Is it working? Thank you for the camaraderie. Everybody got a utility? Everyone got utility? Okay. All right. So when you get a utility, I would like you guys see the name. double click on the name. If you double click on the name, you can edit the name. You can edit the name. Double click on the name, and let's call it, where are we here? Where the project was in Minneapolis, so that would be Excel, okay? Excel, did I spell it right? Excel, Excel. Let's just call it Excel utility, will you? So I'm going to put it right at the top right here. Everybody got that one? Named it? Jeff, are you with us? Okay, good. Okay, double click on the name. Yeah, on the name, not the component. If you accidentally clicked on the component, guys, there's two things here. Every component has two. It's like Revit. You guys remember, Kerry, remember Revit has a tag and a component. If you double click on the tag in Revit, it opens the tag. If you double click on the component, it opens the component. That's exactly the same thing. So if I want to edit the tag, what do? Double click on the tag. If I want to edit the component, double click on the component. If you double click on the component, that's what you're going to get. I don't want you to do that. If you're there, very easy. Can you see that lower X, not the upper X? Upper X will shut the project. Lower X, you can close it. You go back to the one-line diagram. I need thumbs up that we have a utility. Okay, cool. Now, Jeff, you got a utility, right? Now, what do you bring from the utility into your termination box? Anybody can guess? Cables, right? We brought from the utility. Let's go back again to my my Revit. Let's go back to my Revit. Now, the second component that I would like to input is this cable. Can you guys see that? This one here is called the cable, right? Everybody can see. So I started with one. I'm going to go to my cable. Everybody's okay with this? I need to input this cable. I need to input this cable. I need thumbs up, Chad. I know we need us to input this cable. Okay, so let's go ahead and input this cable. All right, so cables. Can you guys see right here? Everybody can see that? New cable. That's your cables. Now, the question would be, Adam said, Chad, is this a cable in a conduit or a cable in the air? All this will come later. This is just a symbol of a cable. It could be cable by itself, cable in a conduit, cable in the air. You decide when you go to the library what type of cable. This is just a symbol. So everybody grab that cable, click it. Are you holding a cable in your hand? Everybody's holding a cable. Can you guys see it goes? Now, do you guys see the circle at the end of the cable? The cable have a circle at the end. If you go there, I don't know what gives an image. If you go there, if you make the two circles match, put the two circles at the top of each other. Can you guys see that? They will connect. One more time. Can you guys see I'm holding a circle right in here? Don't worry about this one. I don't know why it's bringing it. But if I take this cable and put this circle over the top of the other circle, they lock. They connect. Okay, do me a favor then. Grab this and lock them. Do you see what I see when you lock them? You still have that? Okay. Is it there? Yeah, we're good. Good. Okay. What you guys have done, you connected a cable to your utility. Can I have thumbs up, Chad? Cool. Next. Now we're gonna go, if you guys remember when we were doing Revit, we're gonna go back to Revit, step number 3. I need to input, oops, I don't want to zoom too far. At 3, I'm going to have this meter. This guy, I'm going to call it step number 3, right? Because that's my meter cabinet, right? I'm going to bring the cable to my meter cabinet. Cool? So let's go bring a cable to my meter cabinet. Now, a meter cabinet, guys, that's where you have to kind of expand your imagination. A meter cabinet is always called a bus. A panel is a bus. Cool? If you want a panel, you have to put something called a bus. Can I have thumbs up, Chad? A panel is a bus for this program. And for a lot of analysis program, they call them, if you want to do analysis on any panel, they call them bus. Okay? Okay, a bus looks like this, guys. Now think of the bus here, Jeff, think of the bus as the actual cover, the cover inside this panel. Cool? Think of the bus as the cover inside this panel. Okay, do me a favor. Let's go grab a bus. Everybody got the bus here? New bus? Cool. Click on that new bus. You're holding a new bus in your hand. Now, in order to connect it to the cable, all what you have to do, make it touch. In order to connect it to the cable, all what you have to do is make it touch. Cool. When you touch it, is that left click or left click, and off it goes. Now you have a cable. Can you guys see that the tags on the top of each other? No problem, gentlemen. You can grab the tags and move them anywhere you want by themselves. You can move the tag anywhere you want by themselves. You can drag. Can you see how you can drag it and move the, after they're connected, you can drag them anywhere you want and they're still connected. Look at that. You don't do that. But I can drag my utility anywhere I want and still connected. Now, obviously, you want it to be straight like this. I can lower it down, go up, stretch it. Can you have thumbs up, Chad? We can stretch it to get the labels to show. Okay. When you guys are done with this, I would like a thumbs up. We're there. Cool. Now, I'm going to bring this cable here. These cables, I would like you to well, let's go to the bus first. Double click on the tag, double click on it. And this is, what did we call, what do you guys, Jeff, what did you call it in yours? Meter, acronyms, just meter? Okay, I'm going to use acronyms here, guys. Here's the best way to use it with buses. Can you guys use B always for bus, panel. So leave the B, put a dash like this, cool. So every time you see a B and a dash, this means it's a bus, it's a panel. And I'm going to call it meter center, MC, meter center. Acronyms, meter center. You can call it meter, you can call it anything as long as you give it a unique name that matches your one line, your riser. Can I have thumbs up, Chad? Made a mistake? No problem. At any time, you can go and redo it. So here's my meter center. Okay, so every time, Jamie, you see B for a bus, MC is meter center. I'm landing my cable in the meter center. Adam, cool? Now the cable. I would like you guys to go to the cable. Everybody can see the cable. Now this cable is named CBL for cable number 0001. Now when you guys running reports, when you see a cable 0001, you have no clue in a bigger project where this cable is going. To make it easier for you to identify the cables, we name the cables based on the destination, right? So where's this cable going? To MC. So I'm going to call it CBL for cable dash MC. So every time I see CBL dash MC, this is a cable terminated in MC. Can I have thumbs up, Chad? So double click on the tag. And instead of the 001, I want to say MC and leave CB. Now, can you guys see that this is CBL for cable and dash MC, that's a cable terminated in MC. Darren, does it make sense? Yeah. Cool. The naming and the acronyms that we use for the naming is so important because when you guys, we did hospitals and you end up with close to 1,000, 2,000 cables in the whole hospitals. So when you see a cable, 76, where the heck is cable 76? But if you call it cable dash PL1, that's panel 1. I know that this is going terminated in panel 1. So you give the cable a unique name. So when you're looking at them, you know where they're landing. Thumbs up, Chad. Cool. Okay. All right. So let's go to the next step. So you guys are good. Cool. Let's go to the next step. Back to Revit. Where did you go from there? And this is where a moment of truth we're going to have here. Let's go back to Revit. Your riser. Now we're 3, 4. Step number 4 is what? This is my 4. ATS. Everybody can see we're landing in an ATS. That's step number 4. All right, so let's go get at the ATS. Now, ATS, where the heck is my ATS? Somewhere here. Can you guys see that symbol here? This is new auto transfer switch. Everybody can see that? Everybody can see that? That's a new auto transfer switch. Yes, sir?
Are we not coming into the transformer? That's from the utility?
No, this is where the transformer is.
Oh, okay.
We're coming down. This is coming from the transformer. This represents the transformer. Okay. Now we went from the transformer to the meter. Now we're going to go to the CT. Cool? To the auto transfer. Everybody get that one, guys? Click it, please. When you click it, you're holding a big fat boy like this. Now, it makes sense. can you guys see there's emergency, normal, and load? Exactly like any auto transfer switch. It looks like this. Now, do me a favor. Can you, because you don't know where the emergency is, just drop it anywhere. Can you guys drop it just on the side? Just drop it on the side, and it looks something like this. Just drop it in the side. Everybody dropped it on the side? Right here? Okay. Drop it on the side. Cool? Drop it on the side? Okay. So here's my auto transfer switch. Though I can't connect my auto transfer switch to the MC, what do I need between them? Cable. So let's go grab a cable one more time. I'm going to go, I'm going to go grab a cable. Here's my cable. I'm going to put my cable, make it touch the MC, the BMC, right? You can adjust it, zoom out, right? When you guys are done with this, can you give me a thumbs up that we have a cable tied to the MC? Let's go name the cable immediately. This cable is going to be what? This cable is going to be CBL auto transfer switch -1, auto transfer switch -1. Okay, cool. Because we have auto transfer, could be auto transfer switch 1, 2, 3. Okay, so I named the cable going to auto transfer switch. Now what I need to do, guys, is I need to tie this one to my auto transfer switch. Now, Jeff, look at this. I'm going to click on it. It becomes blue. When you see this cross, this means you can move it. Okay, so I'm going to go move it, and I'm going to go make sure it touches the, well, just put it right here underneath it, right? So I'm just putting it underneath it to make it easy to organize it. And see my cable, I'm going to drag I'm holding my cable in my hand. I'm going to make it touch the normal, and for normal. And gentlemen, I have just brought a cable into the auto transfer switch. Made a mistake? Say you made a mistake. What would you do? Made a mistake. You brought the cable into the E, emergency, instead of and normal. Made a mistake, right? Here's how easy that is. Let me just, you made a mistake. Click on it. It's blue now. You selected it. Right click. And do you see where it says disconnect? Right click, disconnect. Now you have disconnected this cable. That's it. So now you disconnect it. I want to reconnect it again. This is as easy as picking it up. Oops, no, I don't want to go into it. Just pick up and make it touch the bus from one side and make it touch that terminal from the other side. And gentlemen, you got yourself a cable that's going to the ATS. I need everybody to give me a thumbs up when you guys are ready. Cool. See how easy that is? Okay, so that's the normal side. Okay. So now I need to go to the emergency side yet. Everybody's there? Cool. Okay, now let's go back and see where we are. If everybody can see that you can zoom and now, Jeff, say you are tight, right? All these were like at the top of each other. You can go select them and drag them, adjust them. It's really nice. The software is really nice. You can move the tag wherever you want them, space them. Can I have thumbs up that everybody knows how they space, they move around. So if they're cramped in one area, don't sweat it too hard. You can space them.
Can you select everything and move it?
Yes, thank you. Select everything and move it. Here's a good, select all the stuff, like in CAD, box them in, and hover over them, Jeff, until you see that cross. Can you see that cross? And then now you're holding the whole thing and moving it in your hand. Everybody can see that? You can move it anywhere you want. Cool? If you want to move anything, you have to select it. It becomes blue. Hover over it. You see the cross. Then you can move it. If you want to move the tag, select the tag only. So if I want to look at this, Jeff, I want to move this tag. Hover over the tag. I'm going to, oops, don't double click like I did. Just hover over it and pick it up and just bring it down here.
Can you expand the whole thing so you make the whole thing bigger?
Yes, absolutely. The question is, can I expand this and make it bigger? Yep, look at this. I can bring this one down here. I can, oops, I can bring this component, oh, I keep double cancel. Click on that one and bring it down. So you can adjust it at any time. Absolutely. Yes, you can adjust horizontally, vertically, but if you guys hold your horses, don't get into the details, because we don't get hung up on the details here and miss the big point. Um, okay, there you go. I just don't want to miss the adjust mine. There you go. Okay, can I have thumbs up, Chad, when you guys are done with this? This is what I'm going to do next. I'm going to do next. By the way, every one of you guys are required to do this. You don't do this, you don't get grade for this assignment. Every one of you. It's not a team. So you're going to go to the riser. When you go to the riser, my friend, the next step that I'm going to do, I hate to move this one. I'm going to go to the generator, Jeff. You see my generator? I'm going to go grab, first bring my gen. This is 5. I'm going to go a little bit faster now. I'm going 5, bring my gen. Then I'm going to bring the cable from the gen. This will be 6. Bring the cable from the gen into the ATS. Can you guys, everybody see that? Cool. Let's go do that. So I'm going to go, I need a gen. Can you guys see where the heck is a gen? Everybody can see the gen here? Yeah, everybody can see it. Synchronous generator, new synchronous generator. Click on new synchronous generator. Gentlemen, you're holding a generator in your hand. What I like to do, I like to put it right by the utility. Yeah, you're doing analysis though. This is not physical. Remember, you're doing analysis. You are modeling the system. That's a model. Cool. Okay. Jeff, click on the tag and name it Gen-1. Is that what we guys call it? Gen number 1. Gen or 1. Because we only have one gen. So call it Gen 1. Thumbs up, Chad. Click on the tag. Now, from the gen, I need a cable. So grab a cable. Go click on new cable. Grab a cable. And I'm going to tie it in one side to the generator. Can you guys see the two circles are overlapping each other? Everybody can see that. When they overlap, just left click. I tied it from one side into the generator. From the other side, gentlemen, I'm going to go tie it to where? Anybody can guess? Thank you. To the E. So drag it. Look how we do it. Click on it. Now it's blue. When you see the cross, drag it. I'm holding in my hand. And down, down, down until it overlaps with, can you guys see how it overlaps? Everybody can see that? When it overlaps, let go and then move it back. And then you can you guys see how I can adjust? Look, mine is ugly, right? So click on this line here. It becomes blue. Then you can move it up a little bit, adjust it. Can you guys see that? Everybody can see that? How you can move it up a little bit to adjust it? When you guys have a system like this, I need thumbs up. Okay. Gary, working or not? Okay. Darren, good. Here's what we're gonna do. Same thing. I'm gonna go to the cable. Double click on the cable. Now I want to remind you this is going to the ATS, but there are two cables going to the ATS, guys. So that's dangerous. So here's what I'm gonna do. I'm gonna say ATS. This is my ATS-1, and I'm going to put one more dash and gen. So the reason why I put this one, because there is already a cable ATS-1 coming from the utility. I need to identify that this is actually coming from the gen. So I named it CBL-ATS-1, which is ATS-1-gen, meaning it's coming from the gen. Thumbs up, Chad? I want to emphasize that it's going to the ATS, but it's coming from the gen. I name based on the destination, not the source. I'm naming based on the destination. But in this case, because there are two destinations coming, two sources coming to the destination, I need to name it, make it unique. Okay, thank you. Gen. Now, guys, if you named it gen, good point. If you named it cable gen, would it be wrong? Absolutely not. These are naming, as long as you understand it. See what I mean?
The standard, you want to do a standard.
Absolutely. Every company that you work on, it's going to have its own standard with naming. This one standard, every company is going to have their own standard. They might name it based on the source. You know? So you name it based on a source, utility, whatever. So as long as you name it a unique name. I like to name it by destination because if I can easily look at this CBL-MC, I know this is the one that feeds MC. I don't care where it's coming from, but I know it's feeding MC cable. So if I go to MC, I should be able to see something tied to it. Yeah. 1 point. But keep in mind, we're only doing feeders here. Branch circuits, we don't go down to the branch circuit level. We're only doing feeders. We'll do the branch circuit slightly in a different way in a second. Okay, I need thumbs up, Chad, with when everybody's is there. Everybody's good? Good? Okay. Now, step number 3, Jeff. I keep picking on Jeff, maybe because you're not paying attention, Jeff, are you? I pick on you today.
How am I not paying attention?
You are paying a lot of attention,
I'm
man.
looking at software trying to.
A lot of attention. Okay, number 6. Let's do number 7. I want to go number 7, gentlemen. I want to do number 7. And I'm going to go also number 8. Number 8. So I need a cable, and from the cable, I need to go to the main panel. Cool? Everybody can see that? So let's go back again. I'm going to go take a cable. Here's my cable. I'm going a little bit faster here. Drop your cable, attach your cable into the other side, the load side, drag the cable. Right at the bottom of the cable, there, my friend, we need a panel. So what is a panel? A bus. Thank you. So I'm going to go grab a bus and drop that bus right in here. I need to stretch it so I can see some stuff here. I need to stretch it a little bit, huh? Oops. If you double click on it and get the component editor, no problem. Okay, where's my cable? Here you go. Here's my cable. I want to drag my cable slightly down. You can adjust them. Drag my feeder down here a little bit. Okay. When you guys hear, can you have thumbs up? Let's go name it. For the bus, I want to click on the tag, double click on it, and you're going to get a B. We're going to call it B dash. Zach, what did you guys call it? MP?
Yeah.
Dash MP. That's my main panel. Cool? Okay, so this is, I know this bus is for my MP. Now, what do you guys think the cable is going to be named then? Thank you. I'm going to double click on that one and call it cable MP. Cable dash MP. Dash MP. So this is the cable that's feeding my MP. Gentlemen, we're good to go now. Any question, guys, about the MP? Okay, so we got your MP. Let's go, what's from the MP, where we're going to go? We're going to go to the receptacle panel one more time. This is a very simple system, so it's not really complicated here. So I'm going to go back, and I'm trying, now I'm getting a little bit, so I'm going to go to, oops, I don't want to move it too harsh like this. Okay, we got here. Okay, I'm going to make 9. Here's my 9. Here's my 10. Here's my 11. And here's my 12. So I need to go to the lighting panel, then to the receptacle panel. Cool? Everybody's good with that? Same thing like we did. Minimize that. So I'm going to go cable. Now, because I have 2 panels, guys, because I have 2 panels coming from the same bus, here's what I do. Adam, I click on this bus and hover over the edge, the end. When you hover over the end, do you guys see these 2 array? Can you guys see that? These 2 arrows here? When you see them, hold, right hold, left hold, and drag. So you can extend from the right and the left your bus. Your bus becomes big, fat, and fluffy. One more time. To do this, you have to pick it up first, hover right at the top of the end until you see the arrows here, and then you can drag to the right or to the left. Then you can size your bus. You can size your bus appropriately. So the same thing, hover over it and size it appropriately. I need thumbs up, Chad. We know how to size it. Cool. Okay. Now with main panel, guys, before I leave main panel, now Aaron was asking me a second ago, and he said, Chad, what happened to my branch circuits? Where am I going to put my branch circuits? Now, this is just a bus. How am I going to show my branch circuits? Right? Main panel. Would the main panel have branch circuits? Yes. So I would like you guys to go to, do you see where it says new schedule here? Everybody can see the new schedule? Everybody can see the new schedule right here? All right, everybody got that? Click on this. That will allow you and just that, and all what you have to do, don't drop it. This will give you the schedule, so you can put your schedule inside this panel. Okay, so all what you have to do is just make sure it's attached to the panel. So then you can go right in here, and what this will give you, Kerry, is it gives you a schedule to put your branch circuit in this panel. Thumbs up, Chad? That's all. Do I need a cable for it? No, because it's just a symbol to allow me to put my branch circuits. That's all it does. Put my branch circuits in there. If I don't care about branch circuits, by the way, I don't need to even use it. Okay, everybody put the schedule. Okay, so I'm going to go click on the name every time, unique name. See what the unique name schedule. I'm going to call it schedule MP. So leave the schedule and just put MP. So when I'm looking at this schedule, gentlemen, I know this is a panel schedule for MP. Everybody's okay with that? That panel schedule for MP. Because Adam, didn't we have a panel schedule for MP? You printed it for me. You can put all this information there. Gentlemen, let's go now. Now we have the feeder coming to the panel, and we have the schedule for this panel. Now we're going to go to a different panel. Okay, what do you do when you go to a different panel? Always do what? Feeder. Grab your feeder, click, make sure it touches the bus. Give yourself some room, guys, and then grab a bus and make sure the bus touches that little end of the cable. Drag that bus slightly, and when you guys are done, give me a thumbs up. Cool? Okay, now I'm going to rename it. I'm going a little bit faster now. I'm going to rename this one. I'm going to call this cable, this is lining panel. So cable LP based on our acronyms that we're using. I'm going to go to the bus, double click on the tag, and I'm going to call this one bus B. We standardize as B for bus, and what am I going to call this one? LP. BLP. So that will be, okay. Everybody's there, guys? Yes? No? Okay. So you have your lining panel. Now, Aaron, what do you think the lining panel is going to have? Schedule. So I need a schedule for lining panel. Gentlemen, I'm going to go stretch that baby, slightly stretch it. Well, actually, I might not even need to stretch it. I'm going to go grab a schedule. You don't need to even stretch it. Grab a schedule. Where's my schedule? Everybody can see schedule. And attach the schedule to the panel, right? And double click on the name. And all what I need to do is just name it as schedule LP. And gentlemen, you got yourself a panel that can have a schedule inside this panel. That can have a schedule inside this panel. The lighting control panel is going to be fit from it. Lighting control panel, Aaron, because it's only 20 amps, we feed it as a load. We don't even show it. Guys, security panel, lighting panel, security panel, fire alarm panel, phone data hubs, all these are 20 amp circuits. They are branch circuits. They are not feeders. So when we do the analysis, they are so-called peanuts. They don't count. They count as branch circuits. That's all. Under 20, any branch circuit count as a branch circuit. Under 20, 30, 40 amp branch circuits, all lumped them. Only major panels, the panel that has branch circuit out of it. You know, the security panel has no branch circuit, power branch circuit coming out of it, does it? It has low voltage stuff coming out of it. If it has low voltage stuff coming out of it, it doesn't count here. Okay, gentlemen, everybody's okay? Now let me show you a trick now. Now that you guys are good, let me show you. Now it doesn't matter if you are Jewish or Catholic or Muslim or whatever your faith is, you have to believe in cloning. That's why I'm bringing the religion here. Doesn't matter what your faith is, Darren, when it comes to the software, It doesn't matter if you're Republican or Democrat. Cloning, you must believe in cloning. I know people are on the edge when it comes to cloning. Imagine cloning somebody like Chad twice. That's a disaster. So anyway, now you're going to hear the word cloning. Cloning, you must believe in cloning in this software. Cloning, Darren, will create identical copy of everything that you clone. Identical copy. The difference between copy and cloning, copy, guys, will only copy either data or symbol. Cloning will copy the data and the symbols. Clone, basically make an identical clone of you of that particular component. So I'm going to show you cloning, very simple. So box in, hold the left. Can you guys see? Everybody knows how to box in things by holding the left click button here. So go box in this area. Can you guys see how I'm boxing in this area? When it becomes blue, give me a thumbs up. Okay. Go hover over it and hover over until you see that little moving. Right click on it. And do you guys see the word clone? Right in here. Everybody can see clone? Now, when you hit clone, don't move. Don't do anything else. So go ahead, clone. Gentlemen, you got yourself a complete cloning system. A branch cloned exactly the same. With the same name, the same label. If you have the information, it will be the same. Now, do me a favor. If it's at the top of each other, is yours at the top of each other? Kinda. So what you need to do now, you're going to be creative a little bit in picking all of them. This is how you do. If you hit control, pick the feeder, hit control and hold control, pick the bus, and pick the three of them, and then you can drag him. You can drag him away. Can you guys see? I cloned them. I just, oops, I don't want to open this. I drag them and move him away. You can hold the control button and pick him up and drag him away. Everybody knows how to do that? Okay. Now, gentlemen, I'm going to do the same thing. Box them in, select them. Can you guys see how you box them in? Select them. Hover over them until I see that cross and drag them all. And look what I'm going to do. I'm going to attach them. See how it becomes fast as you move on? I'm going to attach them. This is going to be my receptacle panel. Isn't the receptacle panel model kind of identical to the lighting? The only difference is the size. So I'm going to go, gentlemen, and drag it and make it touch. Can you guys see how I'm going to make it touch the bus? When you touch the bus, you have just attached it to the bus. When you're done, can I have thumbs up? If you don't want to do it this way, you can do it the old way by bringing a cable and then a bus and then a schedule. The cloning, guys, I could have, look, let me just show you one little thing. See the whole system that I developed so far? And I'm going to go highlight the whole system, right click on it. Don't do that, please. Clone it. Now I have an identical system exactly like that system right next to it. Don't do that. Now, say you did it like Chad, you made a mistake and you did clone the whole thing. What do you need to do? Regardless if you believe in, if you're a peaceful, loving person or if you're a warrior, you have to believe in another word that's controversial here. Destroy. Destroy. You're going to hear the word destroy and clone. Clone, create identical. Destroy key means eliminate this component completely from the graphic view as well as from the database. Cool? So say if you made a mistake like this, highlight it one more time, box it in. So I highlighted it, right click on it, and you can see, where's my destroy? Under clone. Yes, right here. So you don't want to delete. Delete will remove it only from this view. When you, if there's one thing you want to completely get rid of it, what's the word they use? Destroy. So I'm going to go destroy, and it will tell you, are you a knucklehead? You want to destroy it, get rid of it all, yep, and off it goes. That's if there's a component that you don't want at all, that's how you get rid of it. Any comments, any questions? So zoom in, gentlemen, and let's go name these. Let's go name them. So I'm going to stretch my, look how, can you see it's crowded here? Everybody can see it's crowded. I'm going to go click, pick the bus, and until you see these arrows and stretch them up a little bit, right? And then go pick this branch and kind of drag it here. Everybody can see, can drag it a little bit, make sure it's, give it enough room, right? I'm giving it enough room, stretching it a little bit. Now then, I'm going to go to the bus. Obviously, this is not LP0. I'm going to double click on this. This will be my RP, right? We call it receptacle panel for lack of a better name. RP, we have only one RP. And the schedule, gentlemen, is going to be named also what? RP. And the bus, gentlemen, is going to be named, and the cable, gentlemen, is going to be named what? When you click on it. Uh,
Non-unique name.
yes, you have to, if you name it with a name that you already used, you can't use it. It has to be a unique name. So you're giving it a name that's already exists. Check your name that you used. Yeah, it has to be a name unique. Names are very unique. Like I can't name a cable, cable RP, two cables RP. It has to be RP1, RP2.
So if I screwed up earlier and then deleted it, like I screwed up, like I went,
Destroy. You didn't use, see that word where destroy is?
I,
Why don't you name it now something different? I'll show you how to bring it back. Just name it like RP1 or 2, just to get out of that uniqueness. Okay, gentlemen, I'm going to call this as RP. RP. Very good point, Adam. When you use this software, every bus, every schedule, every cable is a unique entity. You cannot give them the same name. Otherwise, remember, you guys doing analysis on these. You're going to have short circuit. You can't have a short circuit on two components that have the same name. It confuses the software when it does the calculation. It has to be a unique name. Unique by a 0 or a 1 or acronym. It has to be unique. Cool? I need thumbs up when everybody have built the system. Everybody built that component? Okay. Now, we have a schedule for each one of them, gentlemen. And we have our riser. Now, you're looking at your riser. You can adjust them. Can you guys see, like, you can grab the whole thing here, see, and I can drag it up a little bit. I can drag it down. I can adjust it. You can make it look nicer. Look at this. I'm dragging the whole thing here and kind of moving him right in the center. So you can adjust it. It makes it look kind of nice a little bit. I can drag this, pick this and drag it slightly to this side. And see what I'm doing here, and grab, you can kind of play with it as you go, and make it kind of unique or whatever. So these are just graphic, really you're not doing anything anything of a value here other than making it graphically cool. Okay, so I'm going to make it look like this. So I have my utility coming in, my gen auto transfer switch transfer, and then here's my main panel with its schedule, and my other panels with their schedule. Gentlemen, you're done building the riser. You're done building your riser. How hard that is. Okay, you guys need 5 minutes and we start inputting data into it? That's the next step. Shall we continue or you need 5 minutes? 5 minutes? Okay, let's take 5 minutes. Next step, I'm going to put data into this system. And the step 2, step 3, what do? Push button, run calculation. How hard is that? Okay, let's give you 5 minutes. And continue with this. Now that let me close my email because I don't want to be bugged. Now that we built the system, I need to do a few things. I need to go input data in the system. The first, now we're going to go back. That's how I do it. Other people don't do it. Let's go back to the utility. Do me a favor. Click on the symbol itself. When you click on the symbol, you open a box like this. This is called Component Editor View. Do you guys remember the Revit when we were looking at Revit when we look clicking on the family? Do you guys remember when you pick the family, it shows the component editor for it? This is your component editor. This one is your component editor. One more time. Click on that. You're going to go to start. I'm going to start from the top, putting data. Okay? See that icon here? Double click on the symbol itself. You will open this window. Give me a thumbs up when you guys are there. Before I do now, the most important thing that you guys are going to do in the utility, Xcel Energy has to give you 2 numbers. Just 2 numbers. Xcel have to give you 2 numbers. They have to give you, you have to fill this information. This information here has to be filled. Right? Can you guys see that? This is utility contribution 3-phase. This is your short circuit. I short circuit 3-phase. You have to get this value, I short circuit 3, from Xcel. Now, Kerry, we don't have Xcel here. So what do? Well, you have option number 1, cry. Option number 2, go to the bar and drink. Option number 3, follow your friend Chad. Cool? So we need to go find the short circuit for this transformer. So for this component, all what you need is just these 2 values. Actually, this value here and this value here. Let me tell you how we calculate them if you don't have it. Let me tell you how to calculate if you don't have it. You don't need to do what I did, but follow up with me. You need to find the I short circuit. Here's what I do, guys, for I short circuit. I short circuit. First of all, to find the I short circuit, you need to find the transformer size. You guys remember my panel is 500. Multiply it by 208. Multiply this one by 1.73. Divide this one by 1,000. And if you guys do the math for your friend Chad, you're going to end up with 180 kilovolt amp, kVA. Cool? That's how you find the kVA for the panel. Why did I use 500? My main panel is 500. Why do I use 208? My system is 208. Why do I use 1.73? My system is 1.73. Why divide by 1,000? Because I need my answer to be what? With 1,000. Okay? 18, this will be 180 kVA. Let's go one more. So 180 kVA. Cool. Step 2. You're going to take 180 kVA, take this one to DeWalt, like you guys have done with me, under 7-7, and find yourself a transformer size. I did that for you, and my transformer that I need, if I am to provide this transformer, is actually 225 kVA. This is the size. This is my XFR size, right? Because it has to be a little bit higher than, has to be equal or higher than the load, right? So assume Excel is going to give me what I asked for, which is 225. Cool. Now, when you reach this point, you need to find the short circuit for it. The short circuit for this. Okay, so the last thing you need to do is find I short circuit. You take the 225K. First, we have to have the full load amp, actually. And then the I short circuit. So I'm going to do that one. So I full load amp equal 225K divided by 1.73 times 208. Let me find how much you can get out of this. What is the page that I used? Page 424. 424. All this guys just to come with a little number here, and you only do it one time for the utility. This is 424. 424. It's already have been done for me, so instead of making, this will be my, I have 625 equals 625. Cool. The last thing you need to do is I short circuit equal 625 divided by the impedance. Now, what is the impedance of this transformer? All these guys, you have to know them. I'm giving you an impedance right now just based on the book that we have right here from when we did the short circuit calculation. Efficient transformer, we're going to be using, for this one, 1.12%. And impedance is 0.0125, I believe. And if you do the math on this, your short circuit, gentlemen, is going to be 62 kiloamp. All this mess is to come up with this number. Okay? All this to come up with this number. Now, this number here, first I have to change this one into amp, and then I have to put right here 62, I think it's in 62 kiloamp. For the low volt, for the line to ground, typically we use half of this. So line to line, 62, line to ground, what's half of 62? 31 kiloamp. Done, gentlemen. Now these values, either you call Excel and you get them. Typically, guys, what we do, Jeff, we get them from Excel. Always, we get them from Excel. If you don't get them from Excel, what are you going to do? You size your transformer and you do a calculation, find the worst scenario for your short circuit available. Cool? Thumbs up, Chad? Okay. So 62, 31. I'm going to get rid of all this. So I'm going to go get rid of all my stuff here. Okay, and go ahead and write in here. Can you guys see where it says, I want you to go change this one into amps. And 62, this will be 62, 1, 2, 3, 4. Oops, 3, Chad, what's the 4? 62,000. And right underneath it, please make 31, 1, 2, 3, 31,000. Everybody get that? That's it. These two numbers are sacred numbers. You get them from Excel or you calculate them like I did. No rocket science. First, you find the full load current of a transformer, then divide it by the impedance. You guys have done that, and you did the homework for me on that too.
I came up with 50,000.
Based on that impedance. Anybody else came up with 50,000?
6.5.
You divide 625 by 1.12.
That's gonna zero and 2,000.
Okay, 50. Let's do that. So 50, maybe I did my calculation. So 50 even. So let's make this one. That's exactly what you based on impedance. Thank you. 50. Here's a 50 here. Another 0, right? And half of this will be what? 25. 25. Yep, 25. Okay. That's basically what you do. I don't know why I followed. I picked the number from the book here. So I don't know. They must have multiplied by 0.9 because they were using the 0.9. But typically, guys, whatever the calculation does that you did, here you can use it. So 50, 25. These numbers are given usually from Excel. How do you do them? The calculation that we did. I should have done the math before I did that. Okay. All right. So done. When you're done, do you see that little cross here? That's the only thing that you need to do here. The only thing. Huh? Darren? Nothing? Okay. So when you're done with these two numbers, make sure they're amps, just cross this. Now U utility is good to go. U utility is good to go. Cool? X out of that component. Cool? All right, now let's go to, now from the utility, guys, I need to go, I'm going downward here. I need to go to my bus, my main panel. Can you guys click on that little icon here, the icon itself? Click on the icon. When you click on the icon, you're going to see a voltage, the nominal voltage system. What's the voltage system that we're using? Thank you. 208. These are all three phase. Click on 208 and exit. Now my system is 208 system. Okay?
I click on the cable on it.
Yeah, don't click on a cable. Make sure you click on that little icon here, the bus. Pick it up, double click on it. You're going to find a voltage, put 208, gentlemen. Okay? Let me see if it picks it up all the way through. Yep. Now, here's the fun thing. The fun thing, if you put 208 here, if you guys put 208 here, the whole system, everything that's connected to it, it's going to be seen as 208. So you don't have to worry about it. The whole system is going to be seen at 208. So this, it will sense that this bus has to be 208, the panel has to be 208, everything has to be 208. You put it one time. That's cool stuff. Okay, let's go to the cable, gentlemen. Double click on the cable, this cable. Now, for cables, everybody's there at cables? Cool. Now for cables. Now for cables, we need to go to the library. We need to go to the library to get a cable from the library. The first thing you need to know, can you guys see what it says library? Everybody's at cable. See what this library? Click on the library. When you click on the library, exactly like the IES files that you guys did for fixtures, these are very equivalent to IES files, except they're cable files for all the cables that God ever created. They're right in here. Every single cable. Do me a favor. When you're there, can you guys see that box? Expand that box immediately. So you're looking at the following. Everybody's looking at that one. That's my cable library. As a matter of fact, guys, this is a library for a lot of stuff. So if you look, we're looking at low voltage because our system is low voltage. What's a high voltage? Higher than 600 volt here. Okay, so I'm going to go, guys, to 310.16. Do you guys remember 310.16? Anybody remember that? Can you guys see 310.16? Now, I want to remind you, Jeff, can you tell me, please, how many runs did you guys do for your system? And what's the size? For this is coming from the service. What was it?
250.
Okay, so we have, when we size them, guys, we use 2 runs of 250s. 2 runs of 250s, THHW, it's wet, in a PVC conduit. Remember, it's PVC, it's wet conductor, so I need to pick a conductor that's wet and in a PVC. Okay, so when you guys look at the volt and the voltage, so can I use THHN here? Can you guys see the THHN? No, we can't use THHN. I'm going to use all the way down to here. Can you guys see that one? PVC, THW, conduit, installation in a conduit, 3 conductors, 3 single conductors. That's basically magnetic. We don't want anybody. Can you guys see the word magnetic here? Magnetic means you're using metallic conduit. Are we using metallic conduit for this? No. So we're going to go down a little bit. Keep going down until you see non-magnetic. Everybody can see non-magnetic? Okay, so here's what I would like you guys to focus on right in, not this one, Chad. Right in this one. And I'm going to tell you why this one. Look at this. This is 3-16. They didn't change it. After she got married and changed her name to 3-15B16, right? That's the one that you use. We're using copper because we're engineers. We kick butts. We don't care about aluminum. We use non-magnetic. What's non-magnetic? These are PVC conduits. They call them non-magnetic. Anything magnetic is steel, EMT, rigid. So non-magnetic is PVC. Anything non-magnetic is going to be steel and aluminum, rigid, intermediate, and EMT. Okay? PVC is the insulation for the conductor. THWN. Anybody knows why we use THWN? We're coming underground. This and I use 4-1/C. This is how this software engineers guys refer to single conductor cable. So look at this. 4 means four cables. Why 4? 3-phase and neutral. 3-phase and neutral. And 1-C means single conductor. They are 4 single conductor cables in a big fat PVC conduit. Can I have thumbs up, Chad? Look at the one above it. The one, actually the one right underneath it with ground. Do I need a ground? No. Between the service and the box, no ground is needed. That's where you can, the neutral doesn't play a whole lot of role. So you really, we just assume it's going to be the same size here. Good point. Full size. Give me 1 second. Everybody's okay with this? How I choose that one? Okay, I want you guys to double click on it. Please double click. When you double click on it, you load it here. And when everybody loaded that library. So now click here. Don't worry about that red stuff. What size did you use, Jeff? 250. Can you guys see where cable size? Did you guys use 250 or 250? Now, did you parallel? Can you guys see where it says, did we parallel? Yep, we parallel too. So 2 sets. And how long? How far? Okay, let's think about it. That was between the transformer and the box. Let's just say 30 feet. It wasn't even probably 40 feet. Less than 50 feet, definitely. So personally, I like to use 50 feet. If you look where they're located on the building, let's look at them. So you're going to do approximation for the right here. So this is the cable that we're using, guys. From here, from the transformer into the box, right in here. Physically, they're located not far away from each other. I'm going to use 50 feet just for the heck of it. Otherwise, you measure it. So I'm going to go use 50 feet. Cool? Typically, you measure that distance, but 50 feet is close enough because you need to have 6 feet termination, pulling, all this good stuff. Thumbs up, Chad. Gentlemen, you have just entered the data about the cables. That's it. That's all what you need to do. Cross out of it. And now your cable is loaded with information about this particular cable. Cool? Now, here's the fun stuff. Here's the fun stuff. Any cable that has the same information, now you can copy data. Let me show you a very simple method. Now, Jeff, help me here. When you guys did let me clean this mess here. When you guys did the size, the generator cable is exactly the same size, right? So I have this cable and this cable and this cable all the same size. Thumbs up, Chad, right? That's what we size it. Then instead of inputting the whole data, and not only the same size, the same type, PVC, everything is the same, identical. So because of this, look what we do. Instead of re-inputting the data, we copy data. So be with me for 1 second. I want you guys to go click on the cable that we just modified. Picked it up like this. Right click, gentlemen. And do you see where it says copy? Yes, where the heck is it? Under clone. Yep, right here. Everybody can see where copy data is? Okay. Now, copy data is not clone. Clone create a fixture like this, a creature. Copy data, just copy what's inside it into that new one with a different name. Okay. So hit on copy data. Then go to the cable that you want to copy in. Pick the cable that you want to copy in. That's the feeder. Right click on it. And do you guys see where it says paste data? Paste the data. Here's one cable done, right? Let's go to the other cable. Can you guys see that cable that's going from the going from the ATS right here, this one? Right click on it, and what do you do? Paste data. Gentlemen, I pasted the data into the 3 identical cables, size-wise. Size-wise. Okay, now let's go click on the generator cable, will ya? Click on the generator cable, open it. Can you guys see it has the same information, same library, everything is identical? The only thing that's going to be different, anybody can guess? Okay. We're assuming the neutral all the same size. The length. So I'm going to go to the length, the one that coming from the generator. Because the generator was further, you guys remember the generator was a little bit further. I'm going to give it another, I don't know. So this is 50. Let's make it 80. Let's make it 80 feet. Okay, 80 feet. The gen will be an 80 feet. That's the only difference, right? The length. Because if you look where they're located physically, the generator is slightly further. Close that one. Yes. I close out of my project? Okay. Open. If you did what I did, guys, and close out of your project, you can go to, okay, that's a good mistake to do. So you close out of the whole project. Cool? Right? Like I did. Very easy. Look how you open the project. Can you guys go project, open, and remember, this is my desktop, and I created a commercial project right here. Click on the folder commercial project. Can you guys see? This is how you retrieve the data. This is your project. .prg. That's my project. Double click on this boy, and off it goes. It takes you directly into this. And if you don't see your riser, if you don't see, look at this. I see a blank, right? I see a blank like this. I open the project, but I still see a blank. If I want to see my riser, very easy. If you go to this symbol here, that shows you the riser. Click on it. Here's the one, my riser that I saved, right? Click on it, and off it goes back into where I was. It's good exercise. I'm glad I closed out of it. Cool?
You forgot a cable,
Okay. You forgot what?
ATS, one cable, you got a copy to that too.
I did, I think. I did mine.
The one going from the transformer to the auto.
Yeah, thank you. We need also to copy to this. Oh, actually, this one is wrong. This one from ATS, we're going to change it. This one here, right click, thank you. That's the one that we're going to paste. Oops, I think I lost my data, definitely. Click here, copy data. Click here, right click, and paste data. In order to verify, guys, double click on this, and here's mine. Now this one is going to the switch, from the meter center to the switch gear. 50 is a lot for that one because it was right there, right? So I'm going to go use 30, will ya? Can you use 30 feet? Because that one right behind the wall. So we have 30, 50, 80 or 70 that we used. Thumbs up, Chad. Everybody got that one? Okay, as long as we're on it, let's go talk about generator before we move into the cables. Well, you know what? We'll do the generator next. Let's just finish the cables since we're on the cables. Now, this cable here, guys, this one is going from the ATS into the panel. What's the difference between this cable? Thank you, EMT. So I can't use this cable. So I'm going to click on it, double click on this cable. I already installed information on it, but it's not right. So I'm going to go to the library again. When you go to the library, my friend, expand your library. It defaults to the last location that you were in. The only difference, guys, I'm going to use THHN and magnetic. So go all the way up to magnetic THHN, 4 conductor per cable, right here. Everybody can see that? I went to 310.16, PVC, magnetic, because EMT, THHN, conduit, 4 conductors per cable, 600 volts. Do you see why I picked this one? Because now we enter the magnetic. Who cares? When you do the short circuit calculation, guys, if your conduit is magnetic, it will be different than if it was PVC. Okay, so double click on it. You got it? Are you sure you're clicking on the same component? Okay, let me see. Give me a second here. Did you guys get that one? PVC magnetic cover. It actually followed. It just changed the library and changed it directly to the same location. Okay, so I have 250 instead of 50.
Once you click on it, it changes it automatically.
Yep. Okay, so everybody's okay. Now, the only thing I want to change, guys, is the 50 feet. Remember, that's going from right there, right next to it. So I'm going to make 20 feet. When you click on it, it updates the information right away. So here's all your info. 250, we're still paralleling, except we're using how many feet? 20 feet. And THHN and metallic or magnetic. Any questions about that? Now my cable is done, gentlemen. Close that. Now, having said this, let me tell you. Now, do you guys agree with me that at least the type of cable and the type of conduit that I'm using between the auto transfer switch and where's my auto? It's not there. My auto transfer switch and the main panel is identical to the type of cable and conduit that I'm using between the main panel and the two other panels, right? They are THHN and EMT conduits. Because of this, instead of going to the library again, I can copy the data and change the size of the conductor. So I'm going to go to this cable, click on this cable, will you? Right click on it, copy data, because the type of cable and conduit is the same. The only difference is the size. Then I can copy it, then adjust the size. Okay, copy this, go to this one. By the way, you can group select now. So I copied this data, hold control, click the other one. I can copy to two cables at the same time. Make it expedite the process. Right click. I'm sorry.
Ground. Yeah, we need a ground in those ones.
We have EMT. Right? We're using EMT. You can, if you want a ground, you can go pick another library. Good point. If I want to pull a ground, I'm going to go pull a new. If we pull the ground, if you guys pull the ground, go to the library, get one with a ground. That's all. That's all. Not a big deal. You know what I mean? So I'm going to go paste the data. Now, gentlemen, my lighting panel is showing everything is right except the size. Now, Jeff, would you please tell me what size for your lighting panel you use conductor-wise? Use 4-aught?
Yep.
4-aught. How many runs? How many sets? One set. Can you guys see how I adjust the one set? And what was the length? The length, guys, right there. So I'm going to use 20 feet. Just for termination, whatever. They're right next to each other. Actually, 10 feet almost. Well, 10 feet by the time you go over and under. Let's just give ourselves 20 feet. Cool? Very close. By the way, when you do short circuit calculation, 10 feet, 10 plus or minus feet doesn't make a whole lot of difference in the short circuit value. Okay. Everybody got 4-aught for the lighting panel and number 1, parallel 1, and the length 20. Close that boy. Let's go to the receptacle panel. Click on that one. Jeff, please, what was your size for that one? Was it number 1? Number 3s. Okay, now I don't have number 3 here. They don't use number 3 a lot, guys, because it's not standard. I have option 4 and 2. Which one do you think I'm going to go? 2. Go up. So I'm going to go 2 because I don't have 3. And how many runs? I have only 1 run, meaning 1 set. And the length, I'm going to make it, leave it 20, right? We left the other one 20. Good. Gentlemen, you have just entered the cables for your system. The cables for your system. Any comments, any questions? Made a mistake? Made a mistake? No problem. Click on the library, pick the right cable. You've seen the only thing you need to pay attention. Number of conductors, insulation, and is it magnetic or non-magnetic? Okay, now check, do me a favor, check the voltage on the lighting panel. See that boss? Click on that one. Can you verify that the lighting panel voltage 208? Yep. I'm just verifying now. Go to the receptacle panel. Can you guys see receptacle panel here? Click on the boss. Can you verify that the voltage for is 208? Just verification. Your system, gentlemen, is running. Okay. Close that one. Now we put all the information that we need. The only thing I would like to do, main panel, ATS. I didn't. Did you guys name the ATS? Yeah, I did not. I'm going to call it ATS. Okay. Do we have one ATS1 just because consistent with what I did? Okay, name it. Make sure you name the ATS. ATS1 or ATS is good enough for me since it's only one. Gentlemen, I'm going to go to my Mr. Generator. I want thumbs up, chat, that we're up with you. Everybody's with me? You're almost done. This is your first time ever doing short circuit analysis with the software. You're going to see how easy. This software, Andrew, is garbage in, garbage out. If you put garbage in, you end up with garbage out. I can give you a very simple story. One time I did short circuit analysis, Jeff, for one of my projects, and I put 20, what's supposed to be, I think like 100 feet. I didn't look on the side, it was 100 mile. And you can't, what a difference between 100 feet and 100 mile for transmission lines. Transmission lines, 100 feet and 100 mile, they give him the mile, the software. So I was naive at that time, giving my calculation to my boss. He looked at it, he just looked at it, he said, no way you can get this short circuit. Go review your calculation, just from the numbers. Review the calculation, end up being 100 feet to 100 mile. Very easy. It wasn't mile, I should have changed it into feet before I put my numbers. Garbage in, garbage out in all softwares. Make sense? So when you guys are looking, make sure, does it say kVA or volt amp? Does it say amp or kilo amp? Right? Always look at the makes a major difference in the calculation. Gentlemen, let's go to generator. Click on generator. I need to go size myself a generator. Okay, my generator, Jeff, is given as, I don't have a library for generator. Let's go change the gen into kW. You guys came up with 225, right? 225 kW. Everybody came up with this? 225 kW. So that's my my generator that we came up with. I don't know if we need to do anything else here for the generator. Looks like everything is. So we put the size of the generator. It's already 208, 220, 3-4 pole. Everything is cool, up and running, and close that baby. And it's a so all what I did for the generator is change it into kW and put 225. Everybody did that? Gentlemen, good. Okay, so what else? We inputted everything. We inputted all the cables, all the buses, all the generators, small system, right? Now, the last thing I want to do before I do the analysis, guys, is I'm going to go to my schedules and put my branch circuits. And that's where the time consuming is. That's what I'm going to show you some, and you guys want to do the rest. Oh yeah, the auto transfer switch. Let's click on the auto transfer switch, see what it can give us. Click on auto transfer switch, will ya? When you trick an auto transfer switch, really not a whole lot that you need to do. Auto transfer switch, maximum voltage library. Can we go to the library, guys? ATS library. Let's go to the auto transfer switch library. Okay, one more time. Go to the double click on auto transfer switch. Go to the library. I need ASCO. What was the size? We said we need a 500 amp. I have a 500 amp. Now I've never did that one. Let's go to a 600. Let's go to first look at the 600 volt. Yeah, let's use. I need a 300, 150 ATS overcome detection device. That's if you have an overcome detection device and a fuse with it, guys. I don't know. I've never used that one. Okay, Chad. Let's use 300 amp auto transfer switch with breaker. Can you guys see that? 300 amp auto transfer switch with breaker. Description, you can get it to 480. My system is 208 though. Not a big deal. The voltage is a little bit higher. So let's try that one, will you? It says 240. Okay. But I need, can I go? I can't go as high as 500 amp. I need a 500 amp, right? I can't go. So let's use this one. Can we? Let's use this one, guys. It says 300 ATS with circuit breaker, 30 to 3000 amp sizes, 480. It fits to it. Cool. Click on that boy. Double click on it. Close it. Oops, the voltage. Can't change the voltage here. Okay, let me see if I can change the voltage. I can't change the voltage. Okay, that might cause some issues with me. Let's go one more time. Can do you guys see anything that can give us 240?
300 ATS with circuit breaker.
Where is it? 300?
Yeah, just two down from.
Yeah, but it's only 400 amps.
There's no 240 voltage with 500 amps.
Yeah. So you might have to go to the 600 amp category. Okay, so, or 800 amp. Let's try it, guys. Let's try it with the one that I picked, will ya? And then we'll see. So with circuit breakers, so try that one. So I'm going to go back here. I don't know if it's going to affect my voltage here. So my size was 500 amps. So I'm going to go to, I don't know if I can do that even. These are all based on 240 though. Based on 240. Can we, guys, just for the sake of it, can we use the 240 right underneath it here with breaker? Let's use this one. Everybody can see that? 200 to 400. Use the 240 right underneath it with a breaker. Here's my 240. I have my 400 amp, and here's my situation. Choose the 400 amp, the largest one. 400 amp, 42, 52 interrupting rating. Okay, I picked that's the largest that I can get. 240. I picked the 240. Okay. Close that one, and we'll see when we do the calculation. We might have to change it, but for the time being, good enough. All right, let's go to the panel. I would like you guys, let's start with the main panel. Can you guys see the main panel right here? Schedule. Everybody can see the schedule. Am I going too fast? Okay. Did you, where do you want me to go, Kerry? Okay, gotcha. I can hold. We're using this. Okay, no problem. Double ATS. I'll go to the, oops, so give me a second here. Let me go to ATS. I'm stuck with, yeah, I'm stuck with the, give me 1 second here. There you go. There's, no, this is,
Bottom, underneath where it says ATS one.
oh, I guess you can do it from here too. But no, give me 1 second, will you? I think I'm stuck with one thing here. That little component. Why can't I? Here you go. I'm gonna pick. Why can't I pick my? This is a bus. My system is stuck here. There you go. Now we're talking. I was picking that little dot. By the way, this dot, let me just show you. Can you guys see this dot? This, yeah, that more connection port. You can change it into a bus by, if you double click on it, that little dot, and it says node. You can unclick on it and make it a bus if you want calculation at this point. Don't do that. But that's what I was stuck in. The connection point. You can make, every time you create a bus, guys, you can do it. Okay, here you go. ATS library. We're going to the right here. Kerry, that's the one that we picked. Cool. You guys good? Yes, no? Okay. Yes or no? You good? Okay. Okay, so we got that one. Now let's go, I'm going to go move this little dot here down a little bit and readjust my system. There you go. Okay, let's go, guys, and to the schedule. Can you guys, everybody zoom right into the schedule? I'm going to double click on the schedule and work on it now. Double click on the schedule. When you go to this schedule, guys, it will tell you you have a schedule or you have a panel. These are all panels, schedules. Let's look at the schedule. First of all, is it overcome protection device? Is it circuit breaker? It's circuit breaker. Leave it as is. Devices bolted on, no problem. Flush, mounting flush. I'm going to take it. It's a surface, right? That was surface. NEMA 1. All this information, take it as a default, will you? I just changed that one surface. Fed from, this particular one was fed from where? Um, that was fed from, well, it gives you the option. What's bus 007? Does it give you the option RPLP, RPLP? These are the only options. So, okay, so leave, because this is coming from the auto transfer switch. That's not giving you an option. Okay, let's go to, so leave this one as, go to the panel. All right, now, you're going to pick, this is where you're going to bring your branch circuits, guys. You're going to bring your branch circuits. So let me go and show you. I'm going to look, this is the main panel, and I'm going to go look at the branch circuit here. I'm just going to do one or two of them, and you guys will do the rest. Equipment panel schedule. Here's your panel schedule. That's Jeff. Jeff, here's your panel schedule, my friend. I'm going to go to the main panel, and I'm going to, can you guys see, Jeff is saying that it's a gas boiler control 20 amp at circuit number 1. Can you guys see that? Circuit number 1, it's gas boiler control. Everybody get that one? Get this one, guys. So I'm going to go put this one. Cool? So let's go. Here's circuit number 1 and single pole. It's a single pole, right? You click on, I'm at circuit number 1. It's a single pole. Description, gas boiler, what was it? Gas boiler control. The size, it's 20 amps. What else do I need to know? Load description. You can have receptacle, you can have heat, capacitor, you can have light. Can you guys see your option of is either a light or receptacle or office equipment or heat or any of these? General load. I'm just going to say general load. You can put yourself a note and overcome protection device size, let's say 20 amp, and that's about it. So that's all I can do. Everybody got that one, guys? So I have GPC 20 amp, lift all the default, general load, single phase, 20 amp size, and bam, that's it. Cool? And okay, so now I have a GPC. I build my schedule. I'm building my schedule. Can you have thumbs up, Chad? We did that first one. Let's go do the second one. Another example here. Click on this. Let's go, Jeff. I'm going to go use, my friend, your file server. File server is 2-pole. Can you guys see the file server is 2-pole? File server right here, 2-pole. This is you guys are going to do them in order. I'm not doing them in order here. Well, let's go to the horizontal unit heater. Let's do horizontal unit heater. This one, click on this. This is going to be horizontal unit heater. Do we have one or two? Number 1, I think. The rated amp for this boy is 20 amp, and the size, what was it? The size for horizontal unit heater, let's just say 20 amp, and okay it. And what did I forget? The type of the load. I forget the type of the load. Let's just say general load. Okay. So I have, oops, did I name it though? I name it to horizontal, or did it put it on the other phase?
Does it matter if you choose heating for the demand? You still just want it in general?
You can heat it. Yeah, you can try to use the best one that you can fit. Remove, copy, modify. I don't know why my GP and AB. Okay, what's single pole? This is horizontal unit heater -1, and I'm going to use this baby 20 amps, and general load, it's on phase B, and okay it. Here you go. So here's my horizontal unit heater on phase B. Okay, any comments, guys? Any questions? So I'm fitting, yes sir.
With the air handling unit, that'd be colder or that?
Okay, now air handling unit, do me 2 favors. Do me 2 favors. The air handling unit, as well as the chiller, the main chiller, leave them alone. I'm going to input them in a different way. Okay, these 2, well, if you know what, if you inputted them, leave them. Not a big deal. So let's go. You know what? Let's go do the air handling unit. Let's just do the air handling unit. So air handling unit is going to be a 3. Can you guys see how I'm going to put my air handling unit here? It's going to be 3-pole air handling unit. I'm going to call this is air handling unit. And the size of the air handling unit in amps, what's my option? My option is in amps. Anybody can, do you remember the size of the air handling unit in amps?
We have 100.
125, no, the full load amp, when you guys calculated it. Do you have it? From the schedule. It should be on your mechanical schedule. What is it in your mechanical schedule, Jeff? The mechanical schedule should have it. Was it 82? Or I can't remember. The air handling unit full load current should be in the first. There's the horsepower and then the full load current amp. 34. Is it 34? 46.2. Thank you. That sounds about right. 46.2. Then the type of the load. The type of the load is motor. Do I have a motor here? Capacitor, heater, office, receptacle, general, spare, general. Okay. Capacitor, spare, light, receptacle, office, heat, cab. Okay. So I don't have it as a motor here. That's okay. So let's just put it in general for the time being. Okay, the full load overcurrent protection. The full load amp is 125. Remember that we put the full load amp 125 for this. And gentlemen, here's my air handling unit. Made a mistake? No problem. Double click on this and it will open it for you. So I inputted my branch circuit into this panel. Okay? Made a mistake in any one of them? I made a mistake with the unit heater. Click on that one. Make a mistake in that unit heater, click on that one. Okay? All right, so you can input when you put the load one more time. Let's go to use the chiller. So I'm going to go click on A. And by the way, try when you put these into your system, please try to match the circuits. Try to match your circuits together. If you can't, I'm not going to sweat it too hard. If your short circuit analysis shows the unit heater on circuit 1, but your Revit is showing it in circuit 3, at this point we're not going to worry about it, but the more you synchronize in, the better. Okay, let's go to circuit. I'm going to put something under circuit number 5. I need a single pole load, and let me go to Jeff's system and see what do I need. I need exhaust fan. I have an exhaust fan, guys. Exhaust fan number 3. Okay, so I have exhaust fan -3. The amp of the exhaust fan. What was the amp of the exhaust fan? What's the amp of your exhaust fan? You have the no, not the full load current. The amp of your exhaust fan. Can you guys look at your exhaust fan for one and see what's the amp of it, please, from your schedule?
Exhaust fan number 1, 5.8.
5.8. Thank you. So that's about right. 5.8. And let's say general load on that. And the type of the overcome protection device we're using 20 amps on that, and we're okaying it. So here's my exhaust fan.
You have to tell them what panel to put it into, don't you?
We're already in panel number in the main panel.
It's not show. Doesn't it have to be highlighted saying it's connecting to it?
No, it's already done. Yeah, we're already in the main panel. You're building the schedule, guys. You're building this. What you're doing here is you're building this schedule. You're building this schedule. Can you guys see that? I'm in the main panel, Jimmy, and I'm building this schedule inside it. Okay, Darren, good? You know how to build these? Either single pole, 2 pole, 3 pole, put the load and overcome protection device. Kerry? Yes, no? Okay. Adam?
Yeah.
You're good? Okay. You guys are good? You're good? Okay.
That's very quick.
Yeah.
The renaming.
Oh, yeah, we'll do that one in a second. We'll bring it back. Okay. So that's how you guys are going to bring all your branch circuits. Fill them in. Close that one. I'm going to minimize this. Now, when you're done, I'm going to go close that. Then I'm going to go do one more load into the lighting panel. Click on the lighting panel schedule. I'm going to go to the panel. Jeff, I'm going to go to circuit number 1 and steal it from Jeff. Jeff's project. Click on the lighting panel schedule. Jeff, what's your lighting panel schedule here? Okay, you're gonna have, here's my lighting panel. I'm using Jeff, and he's saying that lighting control panel is put in circuit number 1. Okay, so that's based on Jeff. I'm gonna go circuit number 1. It's a single pole. It's lighting control panel feed. The load on this one is not rated load. I'm just going to say 20 amps. These are nothing. Load is general load, and the overcome protection device is 20 amps, and no starter, nothing, and single phase, and off it goes. Here's your lighting control panel fed from the lighting panel. Gentlemen, you fill the same thing. The most important thing you need to do is it single pole, 2 pole, 3 pole. Okay, I'm going to go to the receptacle panel and do the same thing. Click on the receptacle panel. Where's Jeff, if you mind me stealing one of your circuits here. Here you go. Where's Jeff? Jeff is using circuit number 1 as GFCI receptacle 113 and 114. Cool? So I'm going to go to the panel, circuit number 1, and I'm going to OK it. This will be R113 and R and 114. It's a receptacle panel, so I really don't need to go say GFCI receptacle. So R113 and R114, you can say here GFCI, just to say what Jeff is doing. The load on this, rated load, just say 20 amps, and the overcome protection device 20 amps. And gentlemen, and the type is receptacle, right? Do I have receptacle here? Receptacle load, and up it goes. Receptacle load. So here's my, I want to go to circuit number 2, click on 2, you go 4, you can click on any one of these and start filling them, guys, up to 42. You ran out of 42, what do? Click on circuits, and you can, like the receptacle panel have to get 84. So make this one right away 84. So I have an 84 slots now to fill, 84 slots to fill. Michelle Cooley Erickson use this software to generate their panel schedules. They don't use Revit. They don't use, for most of their projects, they generate their schedules, panel schedule directly from the software. Any question, guys? Any comments? Any questions? How do you want what? Okay. Any question? Up, down, in between. Okay, I want to remind you, gentlemen, when you go to the lighting panel, I don't know if I did that one, click on lighting panel. Here's my load LCP. If I want to put circuit number 2, let's go see if what Jeff is doing on circuit number 2, lighting panel. So I'm going to go lighting panel, circuit number 2. Circuit number 2. Jeff, you're using the canopy light, okay? So Jeff is using canopy light. Okay, I'm going to go, circuit number 2 is here, single pole. I'm going to call it canopy light. And I'm going to give it a rated amp of 20 and a 20 amp size, and off it goes. Oh, I need, no, okay, so I made a mistake here. Click on it. I need to type the category. The category, of course, it's lights, right? So it's very easy. Lights, and what did they say? 20 amps, cool. Everything is okay, and bam. That's it. So I put a lighting panel with a category load of lights. Any questions, any comments? Every one of you as a team guys must generate this, or you will not get 10 points out of that project. Very clear. Everyone has to have their own. Then you can submit. As a project, you can submit one for the project, but each one of you, Darren, you guys are doing the presentation on this software, right? I can help you a little bit more. Okay. Any comments, any questions? Any comments, any questions? Okay, I want to give you guys 5 minutes, and I'm going to do one more short circuit analysis in it. So leave it. You can fill this info. I didn't fill everything else. I'm just going to show you how to run short circuit analysis. I'm going to give you 5 minutes, recoup, and then we'll do a short circuit analysis on it. And then I'll give you time to build your system and rerun the short circuit after I show you how to do it. Okay? If you hold your horses, everyone, I know you're inputting your data. Hold your horses. You can run analysis at any time. When you do analysis, guys, you can run it at any time. Okay? You don't have to finish the work to do the analysis. The only difference is garbage in, garbage out. If you did not fill all the information, your data is not right. That's all, but you will get data. So let's go run the analysis. So everybody inputted the utility, generator, transformers, ATS, as well as the schedule, right? For the most part. Okay. Next, like I said, guys, we need to go one-line diagram. The first thing, Kerry, my friend, here's a one-line diagram. That's what you guys going to print for Chad. It's done. The second thing is short circuit report. Let's go run the short circuit report. So do me a favor. Come over here. Can you guys see that driver here? That guy says Balanced System Studies. Everybody can see that? Click on this boy. When you click on it, these are the studies that you can run out of this riser. If your riser or if your one-line diagram is right, you should have 0 errors. That's a moment of truth. When you start running the analysis on it, it gives you the moment. If you get errors, not a big deal. You have to go correct them. Okay, the first study I would like you guys to do is load flow. Everybody can see that? Load flow. Click on load flow. One more time. Okay, let's go back. Close that one. Can you see that little driver? Either you can get it from both sides. Run, or I like the icon right here. Balance studies. Okay. The first, you can run demand load, sizing, load flow, or short circuit.
Mine's not, I can't click mine, it's sprayed out.
Can you click here?
No, I can't click the icon, it's sprayed out on the bar.
Are you in this view? Okay. And anybody else's grade? Interesting. Okay. Run balance studies. Interesting. Okay. Wow. Okay, did we save it? No, we saved everything. We have riser. Okay. We called it riser. Yeah, we might have to look at your if you can't see them, just follow up with me. I'll have to look at yeah, let's see exact. Where are we here? Let's go over it one more time. Where is that? Open it and see. If you don't, I have to contact it to get your authorization. So it's right there. Zoom out. No, zoom into it. There you go. I think there's a zoom out here. One of these is zoom out. Okay. Yeah. Zoom out this one. There you go. And try it. There you go. Now it's there. Okay. Cute. Interesting. Okay. Anybody else, gentlemen? Have it? Okay. So let's go to click on studies. Calculate balance studies. When you go there, please click on load flow. Load flow will give you voltage drop calculation in your system. So you can find what the voltage drop in your system, on the feeders at least. That one I want. The second one I would like, guys, is short circuit. Short circuit, you have a couple of options. I'm not gonna get into the details, but the most common one is comprehensive. There's ANSI and there's IEC, different studies that you run. Typically, most of the people run the first one. So take the default. Load flow, give you voltage drop. Short circuit will give you the 3-phase and single-phase short circuit in every single bus, aka panel that you have. Thumbs up, Chad? Cool? Okay. When you pick these, gentlemen, hit run. Here's your moment of truth. Do you have fatal errors and warning? Okay, you're good. Anybody got fatal errors or warning? Okay, so you build the system right. That's your moment of truth. Everybody got no fatal errors or warning? If you have a feeder that doesn't have a distance or a size, it will come as a fatal error. I can't do calculation without the size and the length, right? So that's the studies really, it's not the end of the world. carry, my friend. What it means you have to go back and readjust your system, fix it. Like, for example, the one that you just deleted for you that we destroyed, if they were still there, it will be a failure because they're not defined. The feeder is not defined. Cool? Can I have thumbs up, Chad? We got no zeros. Okay, great. So close that one. Now, where are the reports? Right? We ran the reports. Where are the reports? So two things you have to understand when it comes to the report, when you start printing. So we already run it. Done. Gentlemen, done. So you need the report. You're going to go, if you click, first of all, you click here. These are all your one-line diagram. If you, for example, suppose that I lost this. I'm right here. Lost my riser, right? Lost it. Very easy. Always come to the one-line diagram here. It's always save one for you like this, right? Double click on it and you got back to where you were. Everybody understand? Bigger system, Adam, they give you a bigger system, my friend, you have 3, 4, 5, 6, 7, 10 one-line diagrams running at the same time. So we're only using a smaller system with one line. So, okay, so that's my one-line diagram. All your one-line diagrams, if you want to find the right one, right here. Cool. This one, leave this one. This is the coordination. I'm not going to do coordination today for you. The one next to it, can you see what this says? Reports. Click on reports. Gentlemen, when you click on reports, it opens all the reports that Chad wants you to print. Here's what I want you to do. I want you input report, load flow report, and short circuit report. So when you go to text report, can you guys see text? Let's grab text report. When you click text report, it shows you input report, load flow report, and short circuit report. Everybody can see that? Okay? These are the three reports that you already ran. So I would like you guys to go double click on input report. Here's your input report. This is everything that we inputted from the libraries. Remember that inputted stuff from the libraries for the feeders and all the data, tons and tons of information right in here. Inputted reports about your system. That's what you put in the system. Cool. Let's go close it. Let's go one more time to reports. I would like to go look at short circuit. Can you guys go back to report and look at short circuit? Click on short circuit. Here's the short circuit calculation that you did. Okay, if you guys lose it anytime, go back to here. Again, reports, text reports, and here's the three reports that you can have so far. I'm going to go look at the short circuit. Double click on it. Here's my short circuit. If you look way at the bottom, this is very important, guys, if you can see right here. Fault analysis, way at the bottom. It says lighting panel right now has 17.3 thousand amp. A main panel has 31,000 amp, 3-phase, and main panel bus has 22, and receptacle panel has 13. Do you guys have something similar? Gentlemen, the most important values that you're going to be looking at is this value right in here. So this is how you size your panels to interrupt. For example, if you look at the receptacle panel now, my receptacle panel has 13.3 thousand amp. We sized them based on 35K, right? When I told you to put 35K. So am I good? Yep, good so far. Let's look at the main panel, bus main panel. This one is my main panel. This one says 22.3K, and I size it based on 35K. Good. Lighting panel. Here's my lighting panel. It says 17.2, like 0.3K, and I size it based on 35K. Good. These are the single most important things about this report. Now again, these will change as you start inputting your data slightly. Cool. Now you're going to print this report for your friend Chad. Can you guys see where printer here? Print here. And here's your report, and you hit the print and you print it when I ask you to print the report. Cool. Close that one. Okay. So I'm going to close out of this system. This is my short circuit report. Let's go to the load flow report. Again, every time you want to exit from a report, Darren, my friend, you just X that report. Can you guys see that? By mistake, you X the whole riser. No problem. Come back here, grab that riser or one-line diagram, expand it. Do me a favor, Jeff, go back to reports, text reports, and I need to go to the load flow. Can you guys see the load flow? Click on load flow. Here's my load flow report. For my load flow report, the last page of my load flow report is what I need you guys to focus on. Everybody went to the last page of my report, load flow report. Do I need to open it one more time? Cool. Okay, now let's look at the voltage drop. Here's your voltage drop. Can you guys see the voltage drop right here, guys? This is my voltage drop, and these are my panels, right? So cool, I can see, and here's the loads, all the loads and amps, all the loads in every single panel that I have so far. Everybody can see that, guys? Everybody can see the voltage drop on every panel. The voltage drop on every panel, as well as the shorts, as well as the kVA and the amps on every panel. Repeat. Cool. That's the most important thing. So that will give you what? Voltage drop, as well as load inside your panel. That's what they call a load flow. Voltage drop and load. Any comment, any question about this? Comments, questions? The last thing I'm going to show you, gentlemen, is, so that's your report. Now, print it. How do we print? Just go ahead, print, you print it, and you're good to go. Okay. Am I going too fast? Should I slow down? Yes, no? We told you guys going to be boot camp today for SCM. Wait until you do estimating it with Chad. Might take you 5 hours. So, okay, any comments, any questions? Any comments, any questions? Okay, so we ran these. The last thing, so everybody knows how to run short circuit load flow, very easy. Now what you guys need to spend time, all of you, everyone has designed their own system, is building that riser, putting the information in it so you can get better data. That's all, better data. The system is working. All of you guys have done it right. Otherwise, you'll have a fatal error, or you have other things. You're ready to do short circuit. We did the short circuit. We did load flow. Tomorrow, as I said, I will walk you guys through how to do coordination. We do coordination. The last thing I want to show you, though, is let's do a couple of things. Equipment, let's say transient. Here's all this. If you guys go run, can you guys see where it says run? Run, you can run balance studies. You can have reliability, arc flash. Why don't I have arc flash component? Do you guys have arc flash open for you? Okay. All right. So now it's my turn to close and open. So you have the arc flash run. What did I do, Chad? I have. Everybody has that arc flash evaluation. Okay, so you have arc flash. Mine is not. Huh? Okay. Why did I have not arc flash? Okay, let me see. Maybe I'm inside of a function run. Arc flash evaluation. Everybody else have it? Okay, so let me do one more time. I'm going to go open my system, guys, one more time. Give me a second here. Close and open. And there you go. Run arc flash. Gosh, why didn't you give me an arc flash? Everybody got an, now I'm jealous here. Okay. Did I run? I ran the analysis. Road flow. Okay. Run analysis. Okay. Close. Run arc flash. So everybody has an arc flash. Okay. I might have to use one of yours to run arc flash. Let me see why I don't have my arc flash. Database. I wanted to schedule here. Equipment evaluation, balance three-phase with a ran short circuit, yeah. And sizing run. Okay. Equipment evaluation failure. Okay. Database reports data. Okay. Okay. I'll check mine, guys. I'll walk you through. From there, you can run arc flash. You can go ahead and run it, guys. Run arc flash, and you can see that you can. We're gonna end up printing a label like this. A label like this that says arc flash hazard, PPE, and so forth. I don't know why mine is not working, but This might be authorization where I don't have the authorization. Weird. So I can talk to them. But that's what we end up doing the Arc Flash label from that. For the time being, do me a favor, my friends. I'm gonna stop right here. Tomorrow we're gonna pick up at this point where we're gonna input some coordination. We're gonna do some coordination. So what I would expect you guys to do is to go put all your schedules directly into the system and rerun the calculation. Cool? Import it to the system, rerun the calculation. Any comments, any question for Chad? Comments, questions? Aaron, my friend, we'll see what your issues with that software too. Okay, thank you.